Here is speedrun of grocery store cleanup. The Lambda's VBA can be downloaded at the link in the description. All right, how many of each type of products are in the store? Well, get rid of that thing first of all. Let's do a quick little pivot table. I could use a formula, but I like to do a little click in here. So it's what type of product is what's the price of it, right? So look up. Oh no, it's the inventory, not the price. So sum of inventory. So look up the type of product, get back the sum of inventory, and that's good for level 1. All right, total retail values, price times inventory is price times inventory. This one's not aggregate, it's just an individual item here. So I look up the item on the product name, returning the value. And there's level 2. All right, so now we're going to race inside the store. So in order to get from the start to the end, the start and the end are on opposite sides. So you got to go an odd number of aisles. You cannot go an even number of aisles and still end up at the end. And every time, it doesn't matter which aisles you go down, it just matters the number of aisles you go down. So I got to figure out, I got to solve this like a maze for 1 aisle and for 3 aisles, and then I can extrapolate from there, right? So I've got a little color maze thing I'm going to use. So what if these aisles didn't exist? You'd have to go that way, right? And for this one, like what if you had to go down this one, up this one, then, you know, like this. So you can't cut through this way. And then, you know, you can't go through any of this stuff. You just got to make it to the exit. All right. So now got little subroutines to do no diagonal maze solving. So from 0, 1, 2, 3, all the way to 46. This is just breadth first search. Do not need Dijkstra's algorithm here because every cell has the same value. So 46 and 74. 46 for 1 aisle, 74 for 3 aisles, right? And like I said, it's impossible to have an even number of aisles. So you've always got to go, because then you're on the wrong side of the store, right? So the difference between these, every time you go down, you know, 2 more aisles, it goes up by the same amount. It doesn't matter which aisles, all aisles are the same length. So now I can get the number of aisles, right, by text splitting that, and then I'll just count the number of rows. And then I will get, so this is the number of aisles. This is the number of meters, because the directions say each square is a meter. So I look up the number of aisles on the number of squares, which is also the number of meters. And now I need the time. All right, it says to ceiling round also. So I ceiling round the distance divided by the speed, and that gives me the time. Level 4, now we're gonna go shopping. All right, so I've got to, we're only gonna go, everybody's gonna go to 1 aisle this time, right? So now I'm going to, just gonna move this over a little bit, make it a little simpler. So I'm gonna use filter. I'm gonna filter the things we care about here, right? And I'm going to filter that where the aisle, right, which is D1 to D120 equals, well, yeah, but it's on this sheet, right? Equals the aisle number, right? So that is just aisle 9, price, inventory, aisle price inventory. All right, so I gotta look at what the time. We're always going down one aisle in this case, so it's 46 squares. And there's my speed, right? So the amount of time it takes to run is meters 46. So run time is the distance divided by the speed, right? And this gets ceiling rounded because you use up whatever fraction of a second you have left. So then your starting time is here. This is going to be time left after you grab each object. This has got to be sorted, by the way. Okay. The strategy here is to grab whatever object is the most expensive, right? That's because grabbing every object takes a second. So you want to grab whatever object is the most expensive. So we sort all this by descending price. And then so you're going to take something, right? What are you going to take? So you're going to take the minimum of a few things. You can only take 5 of each item. You cannot take more than the inventory, and you cannot take more than you have time left. So it's the minimum of those 3. And then at the end of that, your time left is this minus this. Actually, this makes more sense over here because it's after that. So you take 5, you got that much time left. That's not how much time you have left though, right? Time left, that's how much time you use. Time left is the time you started with minus your runtime. All right, so now this, and not all the aisles are the same length, so I'm gonna go down some more distance here. And then your dollar value is just some product of, the prices by how many you took of each one, but not the aisles and the prices, just the prices. All right, there's level 4. All right, now we got 3 teams competing, right? So now everybody's not necessarily going the same number of aisles. So I'm going to bring back my aisle calculator here. All right, I'll put this over here. So this aisle thing, I'm just going to look up back in the old place. Why not? So looking up the number of aisles to get the amount of distance you have to go to travel that many aisles, right? 7, I believe, is extraneous, right? With all that being locked, I can just move them over here, right? Like if this was 1, it would just be 1, right? Okay, so now got the number of meters, right? So now the amount of time is meters divided by speed. I want both of those change as I go to the different teams. All right, I've got a couple different tables here. So, ooh, that's bad though. Got a couple different tables here. I'm going to, move this one down to give myself lots of room. Aisles, meters, time. I got to make sure that I remember what order the teams go in. Red goes first, then green, then blue. Right, so this is still red, green, blue over here. So this is now, how many is red going to take? How much time does red have left? And then what's the inventory for the next team, right? Is the inventory before minus the amount that red took, right? I got to fix red's time calculation. So the run time for red is here, and the time limit is the same for everybody, right? So that goes there. So they can take that many of each item. Still haven't taken into account aisles and items yet. I'll do the aisles in a second. All right, so now let's see. I guess I'll add up. I'm going to put in a column for red allowed. Is red actually allowed to take this item or not? Let's see. That depends on what aisle it's in because they're only looking in 3 aisles. So what I want here is, again, these values are all that matters. So can I paste values? Yeah, paste values. I don't need this to change. In fact, if it changes, I'm in big trouble. So is red allowed to take it? Well, if exists lambda, we'll start with x text split, also a lambda, right? So this just will turn this into an array here. And then exists, we'll see if this aisle is inside that or not, and if so, 1, if otherwise 0. Actually, if so, let's say 5. Let's say you could take 5. How many is red allowed to take? Well, if it's in the right aisle, they could take 5. So if it's in aisle 8, that doesn't sound right. Probably this is not getting locked. That's got to get locked. All right, so if they're in aisle 3 and aisle 10, so those they're allowed to take. So now the minimum is not always 5. It's the minimum that they're allowed to take I30, taking into account that they're only allowed to grab from certain aisles. This always goes down to the same place. Now the new inventory is there, right? And now I'm ready to do the same thing for the green team and the blue team, right? So if instead of, so let's say instead of the red team, this is for the green team. And instead of for the red team, this is for the blue team. Green will be allowed to take it based on the green number and the aisle. All right, green takes based on those. Green time left. It's probably good. Is that green starting time? No, it's not. That's green starting time. That's blue starting time. I did my stealing round, right? Yeah. This inventory looks right. Blue allowed has to be based on the aisle number and blue's aisles that blue goes through, right? There's green aisles, there's red aisles. Here is blue aisles. That is time left. And that's, I mean, the inventory left, actually, we don't even care about it, but we can make it correct anyway. So I copy all this down. Let's see how much each team ends up with. So the red team is going to end up with some product of the amount that they took times the price, right? And G, I'll lock these prices in place. So that's the amount they took. And that's the amount that they took. And look at that. If we look up the team name that we care about, right? On the team names returning the amount that they got, then that should be our answers for level 5. All right, double check. Yep, 1,000 points so far. Which aisle has the highest price and inventory? This again is just this. I like to do a pivot table rather than use a group by formula. Just, mouse rather than keyboard, I guess. Sum of value, that's obviously the biggest one. That's what it's asking for, right? Is the retail value of the highest one. All right, the pounds and ounces. Now it is regex time. Let's regex. I got to look for ounces. And I got to look for pounds. So let's say, does it have ounces? Does it have pounds? And then what's the number? Let's do it that way. All right, so regex test. Just want to look for true or false. On this pattern, does it contain the pattern space OZ? Right? Some of these like doesn't. I can't just look for OZ because in doesn't would match. I don't want that. Space OZ would mess up if it was at the very beginning, but it can't be. It wouldn't make sense for it to be at the very beginning. So space OZ should be fine for this. Space LB will be fine for this, except some of these got capital letters in it. which in Excel is usually doesn't care about capital letters, but regex usually does care about capital letters. So now I'm going to make that, which is not the default, but I will make it a case insensitive match. So now I'll get, you see the capital OZ is now grabbed. LB's there. So now the number. Some of these are numbers. Some of these have decimals like 2.5. So what am I going to do? I'm going to do, I can't use my only numbers because that's just going to give me digits. So instead, what I'm going to do is I'm going to look at this text and I'm going to make up a pattern, right? So the pattern starts with /d plus, so any digits. Then there's an optional group of a period, right? So some number point d plus some other number, right? And the question mark at the end of the parentheses means an optional group. Case sensitivity does not matter in this case. So that should be, oh, those are wrong slashes. Those are the wrong slashes. Yeah, there we go. All right, so now I've got either, numbers or an A. So what's the total number of ounces? So if this is true, then it's just that times 1, let's say. I forget if it made it a number or not. Do this is ifs. It says a couple options. So if it's pounds, right, then this, oh yeah, but it's not just of one, it's of the whole inventory. So it's that times the inventory, right? So if it's pounds, then it's that times 16 ounces in a pound times the inventory. And otherwise it's 0. If it's not ounces or pounds, then we're not gonna do anything. All right, so that is $6,435 rounded. I forgot it already. How about this? Equals sum, or equals round, sum of this to the 0, double parentheses. Nope, just one parentheses. There we go. All right, low 5. What is total retail value for the games that Red won? Well, that's going to be pretty easy, right? So did Red win? Let's see. If the max of this equals this, then that means that, that means that Red won. So we're going to count Red's value. Otherwise, it's going to be 0. All right, so just add these guys up. These are the times when Red won. Equals the sum of that. Stop. 18 minutes on the nose. Thanks for watching.